Well, good afternoon. So today we are going to start talking about prototypes, and in particular talking of low fidelity prototypes that will be also part of assignment 2. In the first hour, I will give you this introduction and the theoretical parts about low fidelity prototypes, and including how to do them and how to test them. And then in the second hour, we will do an exercise on low fidelity prototype, an exercise that will start today and will continue next week. So a 3-hour exercise on prototypes. And in the middle, I will introduce you to assignment 2 so that you also know what you are going to do on Wednesday in the labs. But before starting, as always, let's do this, the usual Hall of Fame or shame. This is a little bit more tricky, actually. Do you know what is this? Or do you have any idea what this could be? These are two screens of the same device. Otherwise, I will give you context because I took these pictures. So there is a smart card reader, yes. But what's the purpose of this?
Maybe some floors need some access level. Restricted.
Yes. Where this could be found? No. It wouldn't be in English. So this is an hotel. When you check in to the hotel, they give you a card that is also the card of your room. And close to the elevator, there is one of these screens, just one. And you tap your card, and it will tell you use elevator PA5, and there are like multiple elevators in the hall, PA1, PA2, 3, 4, 5, 6. And PS5, you need to go to elevator 5, and elevator 5 will bring you to your floor. And according to the floor, the system will tell you which elevator to get to go to your floor. So all the people going to the 17th floor will get the elevator 5, and also, but other people will get another elevator. And instead, when you are at a floor, you don't have to tap the card, but you have to select your destination floor. It could be lobby, could be any other floor of the building without the need of having a card. So you can move from your floor to the 5th floor. And this is just this in sense of interaction and screen. You tap the card here, and you are told which is your elevator, and then when you are in the floor that is not the lobby, you have to press one of the other floors, and then it will tell you which elevator to get to go to that floor. So where do we put this system?
Shame.
Who say shame? A lot of uncertainty. Who say fame? Okay, and there is always a good number of, I don't know. So why shame, or why maybe shame?
Because intuitively you don't know what to, or what does PE5 means, or why you don't have a button to press to close the elevator.
Okay, so there are 3 different things. One, you don't know what is P5. You know, because it's written on the elevators, and the elevators are just on, immediately after, so it's visible. You don't know what to do. Yes, indeed, in the check-in area, they tell you you have to go there and press your card, but only in the lobby, because in the floors, no. Just select the number of the floor, and accept the floor you are in, because it's grayed out. And the third one, the third thing? Well,
I disagree because even though it's ugly, it's intuitive. That there's a clear sign with enter your destination. There are numbers. I suppose there are flows. So I just tap one.
this one at the floors, in the lobby, I didn't picture it. In the lobby, you see all of these, all disabled.
Okay.
And then when you tap your card, it appears the elevator. At the floors, instead, you can press them. So in the lobby, all of these is just waste space, waste energy, waste everything, because you cannot actually do anything if not pressing the card. So at the floor, it makes sense, because you tap the number where you go, and it's like this system privilege the optimization of flows and waiting time, and then when you enter in the elevator, you have no buttons. You just need to go there, and you see a small screen that says this elevator will stop in floor number 3, 17, blah, 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 and you have to trust the process or trust the system in this sense, or trust the elevator, and you have no button at all, just one for the alarm, of course, and that's it. You cannot even open and close the doors because it's fully automated. But yes, the ground floor, this is just a lot of waste for pixels and screens, because actually is everything disabled. Once you are on the floor, this could make a little bit more sense, maybe except C. I don't remember what was C. Clear what?
Like clear selection.
No, because this is L stands for lobby.
Maybe it's to call someone.
But it's not like a floor. Like L stands for lobby, so ground floor. And no, because ceiling, there should be one here, well, I don't remember. I was actually there, but I used this, but I don't remember. So this is probably one other things to, because L stands for lobby, so the ground floor, and then these are the other floors. So C is close to floor, should be a floor. Oh no, there was -1. Indeed, it's CL234. They don't remember how they call it, but it was -1. Canteen, but it's not a canteen. Okay, that could be. But yes, numbering and call it -1 could be could be helpful as well. Anything else? On the positive side, maybe. Okay, anything else you notice on the screen that you say could be done better or differently?
There are not all numbers. One.
What do you mean?
Ah,
There are all numbers
yeah, okay.
except 13, because in because in the United States 13 in the hotel are skipped as a bad luck. So they have the floor, but it's 14. They just move from 12 to 14. It's not that it's missing a floor in the hotel. Anything else on the screen? You're going to design a user interface. You should be able to notice something that is not, that could be improved. Here, this is for closing these and go back here. It's for closing the screen, but yes. And what is this? Or this? It's a waste space, right? There's just a bar where you can put the X there, for instance, or some other thing. So this is just empty space, not used space. And this is for the card reader. I don't remember the other one. But again, this is a system that you may find in more modern elevators where the flows are controlled by a computer system, and so you have multiple elevators. Instead of waiting or hoping that will go to your floor, you just have the system to tell you. And this is pretty complicated. In other hotels, you just tap your card, and then just one elevator will light on and will tell which are the floors you are. So you have to read to avoid being in an elevator that will not stop to your floor, but then there are buttons inside, so more similar mix of these with respect to normal elevator. Okay, so this is probably, it's a tricky because it's not bad as a system per se, because it simplifies quite a lot and try to optimize things from like flowing and waiting time. But then if you look at just the user interface, there are ample margin of improvements. Anything else?
Maybe it could be more accessible, like from a graphic point of view. Maybe
Define accessible.
like alternating colors for people who maybe get confused in reading all these numbers in the same color close to each other.
Yeah, maybe, I don't know, colors, well, or different shades. But yes, probably numbers could also be a little bit more. It was big enough. I mean, it's not big, it's definitely bigger than a phone, but smaller than a tablet. So it was pretty big it's not something. So this button were quite big to press. But yes, they are close one enough.
Maybe you should show only the floors that you can select. So if you are with your room at level 17, you have only the button 17 and floor and -1, and 0 and -1.
But this is already the case. So if you are in 17, 17 is grayed out, and you can reach out all the other floors.
But you show it. I mean, you don't have on the screen all the floors that you can touch.
But you can access all of them.
Why? There is no reason why.
It's, once you are in a floor, you can go everywhere in this hotel. It doesn't matter where, like you. It's like you enter the hotel and then you are free movement across floors. So this is done in that sense. On the ground floor, indeed, all this is grayed out with small locks on the numbers because you cannot go anywhere, and that's a waste of space that we said before. Okay, good. So let's just recap again the process so far. So you selected a domain as part of assignment 1. You selected a domain, you selected target user, you select a context, is school, is home, is gardening, is whatever. And then you did need finding in the past weeks, and we also explained to you different ways to do need finding, including observation and interviews. And then we covered last time something about analysis and synthesis, and we talked about sketches and storyboard as two ways to, and tasks. But sketches and storyboards are two ways to express how to satisfy this need in some way that is communicative mostly. And then today and in the coming weeks, when we talk about prototypes, we're going to talk about different level of prototyping, including the ones written here, paper, interactive, and WOZ, that stand for? It's a movie. It's a book also. Wizard of Oz, yes. And then we will continue with the process. So the goal of prototyping in general, also partially storyboard that we covered last week, is envisionment, is making ideas, your ideas, visible. Because one thing is saying, oh, I have this task, I want my system to do this, I want this needs to be solved. But another point is, okay, how we do this, how we can make my idea, his idea, her idea differently and on the table so that other people, whatever they are, can evaluate them, can see them, and we can discuss about them, etc. So all of this is to make ideas visible, generating new ideas, different kind of ideas, but also evaluating new ideas within the team or with teachers in your case, but also with testing ideas with users. And if you remember, we have this several levels of prototyping, because each prototype will, I told you, that each prototype will allow us to learn something differently from the other prototypes level. And of course, we have different prototypes because there are things that depends of the stage of creation we are in. We are just the beginning, like now, or we are 2 months after designing, thinking about what to do. So we are in early stage, in advanced stage, or we're in the final stage, almost ready to do a product, or almost ready to do something to be deployed with like real final user to use it for their own benefit. And then of course, the other things that matter is who is the audience of that prototype. It's yourself, our creator, is for testing with user, it's for showing to a client, is for showing to any management system or manage people in management and human resources, like I did this. And so you need different features, you need different capability, you also need to present things in different way. The error to avoid, and we try to have you avoiding this, introducing and asking you to create tasks before the prototype, is actually focusing on the user interface before focusing on the task that the people has to accomplish. And that's again a preview. That's also why assignment 2 will ask you to create task, storyboard, and then, according to those tasks, the user interface. So prototyping is actually a very nice and flexible method, and it's a series of techniques, and we will see theoretically, I think 4 or 5, and practically 3, to explore different alternatives, different way to do the same interaction, different way to do the same elevator user interface in an hotel. And prototypes will allow us to explore not only flows of actions, but also devices and their role in that context, and different way to do interfaces within that context and within those devices. Because in designing user interface, in designing interaction, there is always more than one possible solution, and it's not necessary that one solution is better than the other, it's just different. And can work well for some user, can work worse for others, can work well on a design system, on a like mobile application, and could work terribly on a desktop. So different devices, different people will require different creative solution. And also it's designing user interface, there are rules, there are principles, we have seen them, but it's also a matter of exploring different possibilities, different solutions, different design, and in a creative way. And it's impossible, even for the most expert user experience designer, researcher, whatever, to find the right solution the first time. Of course, as you are more expert, it will be easier to not make some mistakes, but it's impossible to get the right solution, the best solution at the first iteration. It's always an iterative process in which you will have a variety of designs to discuss, reason, try, discard, and start again, partially or totally. So there are, I was saying, a series of techniques to do this prototyping, to do this envisionment of ideas. One are sketches, the storyboard we have seen last week. The other one are maps. What are maps to you? No. And not even maps like geographical maps. We will see. And then there are actual prototype that could be divided, let's say, in 3 levels. One is low fidelity, one is medium fidelity, and one is high fidelity. And we will see what means fidelity in this context. And then there's also one particular kind of prototype that's called video prototype, that most of the time is between a low fidelity prototype and a medium prototype, where all these prototype, the low, medium, and high prototype have the characteristic to be interactive prototypes. So something you use, not something that you see and observe, but something you have to use it, to interact with, to understand things. So maps, just briefly, for maps, we intend that could be useful as a support tool or for explain the navigation, the information structure of a complex, especially a complex website system application, is a view, a high-level view of the major structure of an interface, which focus on how people move throughout the application. If I am page 1 and I want to go to page 6, what's the path to go there? That's a map telling you which is the path, which is the relationship within pages, between content, etc. And it's again related to the information of architecture of any system. So if you go on a, well, old style mobile phone, like the cordless phone that you may have at home, you typically have a circular menu where you start like in, I don't know, phone book, and then you go to settings, and then you press next and go to calls, and then you press next and go to alarm, and then you start again, a loop. This could be a map of how this is depicted, how this works. So you don't know the exact content of the page, but you know that if you start from messages, inside the message you have inbox, outbox, etc. And then after message you go to call, and then to settings, and then to office task, and then to connectivity, and then you continue this loop. Once you arrive to again to network service, you start again from book, and then messages, etc., etc., etc. So this doesn't tell you how this menu appear, but tells you how the menu work in a information way. Where is the information? How can reach it? So from here, messages with 3 next, I will go to office task, and with 3 back, I will go to again to messages. So it show me how to navigate the space. In the web space, you probably have seen them as a sitemap. So maps that from one page will tell you how to go to any other page. In theory, again, doesn't tell you what is in the page, what's the content of the page, it just tell you how to navigate. So from the home page, you can go through some search to the search result, or you can go to any of this page, how? Through some menus, through some links, through some boxes in the home page. It doesn't matter for this visualization, but the important thing is that you can do this, or you should be able to do this. So if I have this sitemap, this information, visualization, and I can tell you, do a website, and also providing the content, of course, do a website that works like this. And then you can use whatever technology, whatever layout, whatever framework, whatever colors, etc., to represent, to redo the same structure. So you design the navigation map of the website, you design how the information is connected, and then with that, any developer could develop the actual system following the same logical processes. So these are maps, just to give you this example, and especially on the website, maps are still very popular and still used to represent this. So if you need to communicate to someone how the information is structured in your application, you can use map to show them without having them to navigate the entire website, the web application, mobile application, whatever, to discover all the pages. You can show them and say, is something missing? Maybe it's an expert of a domain, maybe is your boss, maybe it's the client that gives you any like requirements for this, and say, oh, I want all this information laid out. And you say, okay, this is how I would like to lay out all this information. Is this fine? Is something missing? Even before actually doing everything, actually write the content. So faster and sooner than actually implementing the code. Prototypes go a step further than this. Instead of just representing our information as a layout and how to navigate between information, it gives you, as written here, tangible approximation of a system to again generate, evaluate, explore different decisions of interaction and interfaces in a way that is quick. So that's why also we don't go with let's do a prototype in JavaScript, Python, whatever, but we prototype multiple times with different level of fidelity, where one for have you learned how to do this, but also because as we will see for low fidelity prototype is way faster to do 5 or more low fidelity prototype than one complete like application in code. So what is a prototype in general? A prototype is a concrete but partial representation or implementation of a system design. And we have seen some example of this in various levels of fidelity. Another definition is an easily modified and extensible model of a planned software system, likely including the interface and input-output functionality. So concrete but partial representation means not everything should be present in the prototype. We already said that. When you will create your prototypes, just ignore things like login, sign up, etc., because that's not your final goal, that's not your purpose. And also easily modified and extensible should be something you can quickly remove apart and redo it quickly, easily, without spending weeks on that. And it's actually one of the most powerful tools for design exploration, visualization, and testing, and because they allow us and any people to see and feel how the interactivity, how the user interface work in various, again, degree of fidelity. So this is a prototype of the existing device on the other part of the screen. So this is a little bit old, probably. Do you know what is this? The black thing? Describe it in more than one word. What's the purpose of this? What was the purpose of this? This was before smartphones, before tablets.
From what we see on the left, it's a digital agenda.
Is a digital device. This was the Palm Pilot with a pen. You can write here, and there are buttons, and you can have menus. You can write and write. You can have agenda. You can have phone number. You can also do some calls. They disappeared as soon as smartphone appeared, and they were not even much popular before, just in some business area. But this was a good share of market for this, and Palm Pilot of US Robotics was one of the main vendor of this thing. What is on the other side of the slide? Okay, let me do another question first. To do this, like imagine someone go to you and say, okay, I want to create this. Both the hardware and the software. How much time and how many people will need to do this? Estimate. Depends from what?
Depends on the resources. Depends on the resources.
I'm asking you, I will give you resources. Tell me how many people and how much time that, and we will see if there are like financial resources enough to support all these people for all this month or years or whatever. It doesn't need to be the right answer also, because I don't know the right answer, but let's approximate. Is something you do in 1 week? No. Hardware and software. It's something you do in 1 month? 1 year. More reasonable. Not alone. Because you may need someone for the hardware part, someone from the user interface part, etc. And how big this thing should be? It's like 10 centimeter per 10, it should be squared, it should be rectangular, it should be... How can you decide? Testing what? After 1 year that you do this? When to test? Yeah, you can test it. You can say, okay, I have this, try it, and if it's too small, I will make it larger, but not after spending 1 year and 10 people to do this. And the weight of this device, this should be black and white or colored. Should be 1 kilo, or should be 100 grams, it should be 20 grams, and the pen, is needed the pen or not? How big should be inserted somewhere? All these are design decisions. And if you're creating this as a new product, it sometimes happens that you have a new product, like in this case, you have no idea. You maybe know that should be an agenda, or there should be a calendar, and there should be the ability to take notes, but that's also a laptop will allow you to do this. So you want to create something portable, more portable. So how these actually people did for Palm Pilot? They create a prototype. So this one is a prototype of that device. They took a piece of wood and they printed the interface and they carried around for a week. Working on this piece of paper with a pencil that is here. And if this was too big or too small, they just cut the piece of wood or add another piece of wood, and they reprint the user interface, and they figure it out in this way, which is the ideal weight, because these people will bring in this with them for the entire week, for the entire day, this object with them. So if it was too heavy, or too big, that would be uncomfortable for them. So it seems strange, if you think, going around with a piece of wood, with a paper, and trying to, like, adding notes to something that is not really adding anything, because it's printed, it's fake, but gave them the capacity to understand the constraint that they had, size, if the pen is needed or not. The first version didn't have a pen, but then the interface was smaller for a finger. And the first version was bigger, and then they need to cut down, and was heavy, and they need to make it less heavy. So with a few weeks, a month of a piece of wood and a paper printed on it, they had a series of constraints before actually starting and understanding if it's feasible to produce this device. If the results was, oh, this device should last, should be 1 gram of weight, they could say, okay, we will never do it. It's not possible to have a battery and a pen in 1 gram. So they needed to understand which are the constraints, which is the form factor, which is the user interface. And they also had a user interface here, so they can understand if with the pen, they can select these, if people understand which are the icon, etc. So it's rudimentary, but was the way to say, okay, let's decide something, because otherwise I cannot produce this thing. And they did this in, let's say, 1 month. They had all these constraints, and then they started to understand, okay, it's doable, it's feasible, they have the resources, and they will try to produce it. And then there will be multiple versions of Palmars in Palm Pilot, also HP did other Palmar, but all of them has the same form factor, all of them have the same pen, all of them more or less the same weight. What changed was the user interface a bit, was the modern where modern version was a colored display instead of black and white, and then there was a Windows version also of the operating system, but the basic things started from a piece of wood and a piece of paper. So same question before, how much time and people needs to do a prototype like this? Before we said more or less 1 year and multiple people and a certain amount of money, and then we don't know a lot of things. To do this, if I tell you I have wood and a printer here and a pen, how much time do you need to do one of these?
3 hours.
How much? 3 hours?
Maybe an hour.
Maybe an hour. So let's say hours instead of years. So we just scale down a lot. Even if we say day, 1 day will be a huge scale down with respect to that. And that small things obviously cannot allow you to understand what you cannot understand from here with respect to the final product. There are things you cannot understand from here, right? What you cannot understand?
Functionality.
That functionality, you change the piece of paper, you can have multiple functionality, more or less.
Like limitations in the hardware, the real actual device.
The real actual device is like this, more or less. What you cannot understand from this kind of prototype?
How the pen works.
How the pen works means?
If it writes well on the screen or
The speed of writing, the pressure you have to put on the screen, the quality of the rendered pen, all these things you cannot understand. You cannot understand the reaction time if you change from one application to another, because here, if you want to change application, you change a piece of paper. So you cannot understand the quality of the audio if you use this for a call, because you cannot call with a piece of wood, of course. So there are things that you cannot understand with this, but this is a low fidelity prototype. Something you can do quickly, you can change quickly and still give you various information that you don't have otherwise. And if you wait to do the final product to have this information, you will just waste years. Same apply for software, even if there is no hardware in a sense. So this is an extreme, let me say, case in which this person, which is quite common for the hardware part, in which this person brings with them this piece of wood with this piece of paper, and they change the paper like it was the real device, but it was not, to understand the ergonomics, the weight, and all this stuff. How small and big the button should be, etc. But the same apply to software in a smaller sense. But in both cases, the low fidelity prototype on software is easier because you don't have to cut wood in first place, or to print something because you don't need to carry it with you for weeks. It's just a more static, let's say, experience. So we have different level of prototypes, as we said, and each of them will tell us something, will facilitate conversation about something. So the storyboards, as we said last week, are all about task. So if you show a storyboard to someone, they will be able to understand which are the tasks that the people is trying to do with any device, software you are creating. The low fidelity prototypes allow you to understand interactions. How I use this, similarly to the wood Palm Pilot. It will not allow you to understand visual design, for instance, because it's too low in fidelity. The medium fidelity will allow you instead to understand the visual design, a pixel level visual design. And the high fidelity prototype will allow you to understand more usability details. But if you start from here, you will learn a lot about user interaction before starting to focus on the visual design and before to starting to focus on everything else. If you start from the high fidelity prototype, you will have to understand everything here. So it will be a lot of factors to consider instead of moving factors to different level of prototypes. Again, in a way that is quick and easy to do, and allow for testing if needed in multiple stages. So you have seen already an example in the first week, but let me do another example of low fidelity prototype and a medium fidelity and a high fidelity prototype. This is an example from this course of a few years ago of a low fidelity prototype. So, what is this? Like a smartphone. So this is an application for smartphone. And what's the topic of this application? What's doing this application? Or this page? Universities, and then in particular, it's a exam, and then it's a task. So some task to work on exams with like deadlines. I don't know if you see them, but here there is a calendar and there is practical, so probably it's a task that could be theoretical or practicals. And then there is next and previous, so you have multiple pages. So low fidelity prototype lays out the main information, the main interaction in the site choice. They decided to have a title, 2 cards, and 2 buttons. And there are tons of missing details. Colors, size of buttons, precision of elements. And that's totally fine because you want to focus on the interaction, not on the fine grade levels. This is the high fidelity prototype of the same device, the same application. You see, there are changes. The previous and the next disappeared. The previous became the arrow. Still card-based. Still tasks you can write, but they are ordered by dates instead of having the dates inside them. So they started with a low fidelity prototype, they tested it, they discovered that something wasn't working, and they proceed until to receive it. And this looks like the final product, looks like a mobile application, but it was not. It was a prototype, incomplete prototype that was doing some operation very well and totally nothing on other things. To prove the point, to satisfy your solution, if you want to phrase them for the assignment. Then prototypes in general have different characteristics. We'll see some of them. Well, one is the purpose for which you do the prototype. You can do the prototype to evaluate an interaction or to evaluate some technical aspects. Like before, we were saying for the Palm Pilot, you want to understand which is the optimal size of the screen. That's a purpose. Or the role of a product. It's better tablet, it's better smartphone, it's better desktop. Let's try to explore different alternatives. And once you have a purpose, you can also understand what you want to check. Do you want to do an expert analysis to test it, like the heuristic evaluation you will do? Or you can check them with design principles. Or you can involve users, like with the Palm Pilot. They will carry with them these wood things for a week or for a day and see how it works. So there are different levels of purposes. Then there are prototypes that are just exploratory, or let's explore things. Let's do 3 prototypes, and then let's throw away one of them or 2 of them, and let's keep one. Experimental, if you want to validate something specific, or operational, that is an iterative prototype that is refined over time until it becomes the final version of the application, of the system, etc. And there are 3 models for durability. One is a throwaway prototype. You do a prototype, you throw away. You do another prototype, you throw away, and like this. One is incremental. You develop the entire system incremental, and then in modules, and then you refine or redo a single module. Or the evolutionary prototype, where the prototypes becomes the product, and each iteration builds upon the previous one, which is similar to what we are going to do here with different level of fidelity. Then you can have a global coverage, meaning the prototype will try to do everything, or a local coverage, meaning that the prototype is just testing one existing feature, and everything else is like it was before or not important. And similarly for the completeness, the fidelity that we already discussed, and the usage. A prototype is static, like a storyboard, like a diagram, like a map. You can just look at it. Dynamic, like a video, or interactive, which is the majority of the prototype. Here there is another example between a low fidelity prototype and a final product. What is this in the final version? Yeah, some old Microsoft printing settings for paper size. And on the other side, there is the low fidelity prototype, where you can see like the same elements, but it will allow you to understand, okay, oh, here there is a preview, here there should be buttons, here should be orientation, here should be the things I need to do. And again, drawing this in black and white with this quality is probably half an hour, thinking also what to write in it. Implementing this in C++ or something like this is probably a little bit more than half an hour. Just the interface with the options, etc. So again, different information is conveyed. Of course, here you cannot learn many things that you can here, but also it's easier to do this, it's quicker to do this. So we already talked about low fidelity prototype. One kind specifically, which is the most common kind of low fidelity prototype, is the paper prototypes. That's the one we are going to ask you to do, which means you have to do it on paper, like actual paper. And a paper prototype is an hand-drawn mock-up of the user interface on multiple pieces of paper or varying size to represent a user interface. So the key feature of a paper prototype is that it has to be interactive. So you have sketches of the screen appearance, where each piece of paper could be the full screen, could be maybe just a dialog box, could be a menu, could be a part of it, and you can move it on top of the larger page, all on paper. The interaction is natural. If you want to click, you just do it with your finger. And if you have to type, you have to write. Or you can show a keyboard and people have to click on a keyboard. When you want to try or to use a paper prototypes, you have one person using it and the other person being the computer. So simulating what a computer would do in a implemented system. So we'll put down pages, put down screen, pieces, and if I click somewhere, the new page will arrive, and so they will move a new piece of paper, etc. According to what happens, what the person do interacting with the prototype. So it's a low fidelity look and feel. It doesn't look high fidelity, it looks like hand-drawn quickly. Low fidelity in look and feel, but high fidelity in depth for, again, the user interaction. Because all the interaction are possible and you can understand if what you think, where you put the buttons, etc., is reasonable or not, or it has problem. Because you have this person that simulates the computer, in a way, the logic. How to do paper prototype? That's very easy. That's kindergarten stuff. You need paper, pens, markers, post-it, scotch, glue. You can have photocopies. So if you have, like, I don't know, the same warning message, you can photocopy it. Or you can print out a screenshot if you need it. But that's what you will need to do in assignment 2. It's a paper prototype. Pick a piece of paper and draw on it. Or small pieces of paper and draw on it different kind of the interface to test them with users. So kindergarten material, there is no specific skill that you have to, if you know how to use a pen and a scissor, you are fine to do this. So why doing low fidelity prototype or paper prototype? Well, again, one key reason is it's way faster to build. Drawing something like this is way faster than programming something like that in whatever programming language. Even it's faster than telling ChatGPT or Claude or Cursor to implement that and refining them, because sketching is still faster. It's easier to change. You can pick a piece of paper and throw it away and start from scratch. You can make changes very, very easily, and there is no investment in code, no investment in everything, because again, it's a piece of paper and a pen. Most importantly, when you have people using this, you have them focus attention on the big picture, not on details like colors. Because it's proved that when you have people looking something that looks like an high fidelity prototype, looks colored, is precise, etc., I will start to nitpick. I will start to say, okay, but this shade of red is wrong, or this button are too close, or I don't understand this, or I don't see this very well, or the contrast is wrong, etc., etc. With paper prototype, you don't have any of these comments because there is no color and there is no precision. So people cannot complain on those things because those things are not present here. They will be in a higher level of fidelity, but now you can focus on the interaction without focusing on these details, which are important, but after. And also non-programmers, if needed, can help, because again, kindergarten skills are the one needed. And here there are other examples of paper prototypes, some taken from, I don't remember where, and some taken from this course. And then people get creative. So here you have a mobile application, Mac Home, this is taken from this course, I think, where they draw the pages. And then also have these small pieces of paper to replace or to add on the screen if something happens. This is done with stencil, so you can just draw in the boxes. And this instead is a tablet application where they also draw and create the border of a tablet to make it more realistic. So they don't have a piece of paper on the table, but there is a nice border that's where you can put in the piece of paper, etc. These are other examples. Paper prototype, you see something easy to do, quick, black and white. Even the Windows terminal, the tab bar in Windows terminal was prototype on paper. As you can see here, one portion of it, not the entire terminal, just to understand and show to other people how it would like before implementing this for real. And of course, paper prototypes have the problem that they are single pages. So how can you create flow with paper prototypes? And you can. And here there is an example of a paper prototype of an email application in which you can see how they create flow, and you can also do the same if you need to create the same level of flow. You see the person tap on it, and then there is another piece of paper that's normal, and then press on recipient, and then it's enlarged, and there is multiple fields, and then you press on a field, and it's a drop down, so you have the piece of paper. This is upload a file, you select the file, okay, and the file is uploaded, and then there is the file appearing on the interface, and then you press another thing, and a drop-down menu, and a drop-down appears, you select something on drop-down, and something happens in the interface as well. And then you send the email, and the email goes away, and you go back on the previous version. And then you click and you receive email, and you will open it. So this is how a paper prototypes work. The person in white is acting as the computer, and the other one is the one testing it. You can understand all the interaction. You can understand if the buttons are working or not, and this is extremely simple, almost ridiculous, but it's extremely simple to do. And even more complicated interaction, just a piece of paper that can change or shrink or enlarge at the action. So if you are well prepared, you have all the pieces that you need in your interface, this interface has a lot of drop-down buttons, etc., you can recreate something like this easily. So to managing flows. Also, if you need dynamic screens like swipe on the left or scrolling on the left, etc., you can use one of the, let's say, draw a mock-up of a smartphone or a tablet, etc., and have piece of paper that can move in horizontal direction. So you have on this page, if I press book section, the computer will just move this piece of paper on the left or on the right to give me the right screen. And here there is the same example with the smartphone. So the smartphone, a slide to unlock, I will go here, and then if I do some operation here, I will go here, and then I will slide it. And then the same thing also for a smartwatch, where instead the sliding is up, down, and not right, left. So this is to create a dynamicity in screens if you need to move, to swipe one direction or the other. How to test a paper prototype? You need, similarly to the interview, you need an observer, a facilitator. So the facilitator in the interview was the one that was asking question. Here is the one that present the interface and the task to the user and encourage people to ask questions, to think aloud, etc. And then there is the observer, similarly to the interview, where it stays silent and takes notes. But most importantly, here you have the computer. You have a person that does the work on the paper interface like the one in the video. So gives a new piece of paper, remove the old piece of paper, etc. Just simulate the prototype and does not give any feedback that a normal computer would do. So if the computer just give an error, just present the error on screen and stay silent, because the computer will not try to explain what you want to do. It will just give you the piece of paper or the piece of information that is consequent to your action. So this is in general to test a paper prototype. We in particular, we will test it through a usability testing, an heuristic evaluation after our feedback. So that will be slightly different, but also in that case, you will need a computer, of course, to manipulate the piece of paper and someone that looks what happens. But you will get more details when we talk about heuristic evaluation. So what we can learn from paper prototypes? As I said before, we can learn user interaction. We can learn conceptual models. We can learn if there is a gap somewhere between what I expected to do and what the system expects me to do. I can understand if all the functionality is there, if there are any missing feature, if there is anything that doesn't work. I can understand navigation. I can understand the flow. If people get stuck, I can understand, because they will not press anywhere, and they will tell me I don't know where to press. How can I go back from here? And also I can understand sort of screen contents. I can understand what needs to go on the screen. If I want to put 100 information on the screen, can I draw 100 information on the screen or not? It's not precise, but still gives you a rough idea. What we cannot learn? We cannot learn, of course, colors, fonts, white space, layout, because it's on-drawn and it's in black and white. We cannot learn about efficiency issue, because it's made on paper. We cannot learn response time, again, reaction time from a computer system, because there is no computer system. We cannot even learn if small changes are noticed, because in a paper prototype, even a small, tiny change will involve a person picking a piece of paper and putting it in front of me. So all changes are major from that perspective. With respect to a computer, that instead maybe will just change the border, the color of a border in the top corner of the interface. So that is not something that a low fidelity prototype will allow us to understand. And we cannot learn if it's more exploration or deliberation, because with a paper prototype, people are typically more deliberate in what they do instead of exploring and clicking things around and trying to do things on their own. Also because you have another person that actually do the computer and move his pieces around. Okay, so this is the first level of prototypes. which is low fidelity prototypes on paper. We will have other 2 levels of prototype, a medium and a high fidelity, and we then focus much more on the high fidelity prototype in the future than not on the medium. In the next weeks, after this paper prototypes, we will talk about all the things that you need to do a medium and high fidelity prototypes, like color, fonts, white space, feedback when you have colors, response time, etc., etc., etc. All things that you will need to bring before doing the high fidelity prototype. So the next weeks we'll also focus on these aspects, visual design, etc., and on heuristic evaluation, which will be the next thing you need to do for evaluating the paper prototype. Okay? Any question up to here? Yes.
Like when we want to do the low fidelity, how many or how much feature we need to consider? Because implementing all of them on the paper would be really procrastinating or like time consuming or whatever. You cannot cover all the details, what we said, just main features.
In general or in particular for your assignment?
Like generally maybe.
Generally, it depends what you want to prove with the prototype. Again, rarely a prototype is 100% fully completed system, but if you do a prototype, it's because you want to understand how to do something new or differently, and so that's the part that you want to test. So it could be, like in that case was, in the case of the video, was a paper prototype on sending, receiving email and contacts. It doesn't have a calendar because that was not their purpose. So it depends what's your goal beforehand. You can also draw a fully featured system, but the question is, does it make sense or not? Like having a login page, does it make sense to draw it or not? It's pretty standard, so probably does not make sense. So for the things you want to explore that are core to your system, to your application, there it makes sense to do a prototype, to start with a paper prototype.
For our assignment,
I will tell you in 10 minutes. Or after another question, if it's before. Okay, so let's move to the assignment.